So a little bit of review here on our new unit, data analysis and probability. Two important vocabulary terms here. The possible results of an action are called outcomes, and a collection of one or more outcomes is an event. We talked yesterday about the fundamental counting principle. There's a long description here, but an event M, capital M, has M, lowercase m, possible outcomes, and an event N, capital, has lowercase n possible outcomes. The total number of outcomes of the first event followed by the second event is multiplying the number of outcomes together. That's not too bad. So we're going to use that, oops, when we talk about probability. When all possible outcomes are equally likely, we can find theoretical probability of an event. It's written as a ratio of the number of favorable outcomes to the number of possible outcomes. So, as a fraction. You can say P and then in parentheses the event, the thing you're looking for. The number of favorable outcomes, the number of things we're looking for on top, and the number of possible outcomes on the bottom. You can write ratios in other forms, but the fraction way is the way we're going to be using it. So here's an example. We randomly choose one of the letters in the word Florida. We're going to find the theoretical probability of choosing a vowel. So I have to know the number of vowels, the favorable outcomes, and I need to know the number of possible outcomes, the number of letters. So how many of these are vowels? 1, 2, 3 of them. And how many letters are there? 1, 2, 3, 4, 5, 6, 7. 3/7 is the theoretical probability of choosing a vowel from these letters. If we look at the theoretical probability of choosing an R, the favorable outcome is choosing an R. There's only one R. There are still 7 letters, so the theoretical probability is 1/7. We can use theoretical probability to make predictions. So let's say we know that the probability of choosing a green marble at random is 3/8. If 3 out of every 8 marbles is green, we have to figure out then, out of 40 marbles, how many are green? So what number would make these two fractions equivalent? 8 times 5 is 40. So 3 times 5, sorry, I got 4, is 15. There are 15 green. Here's another example. The theoretical probability that you spin an odd number is 0.6. I don't know what this spinner looks like. Something kind of like these things, but it has 10 sections. So we can figure out how many have odd numbers. What's 0.6 as a fraction? Based on place value, 0.6 is 6/10, which is the same as 3/5. So 3 odd numbers for every 5 total. And we know there are 10 sections. How many have odd numbers? 5 times 2 is 10. So I can do 3 times 2 to get 6 sections. That's my final answer. An experiment is fair if all of its possible outcomes are equally likely. So this spinner, it's equally likely that you get 1 or 2. It's equally likely you get red or blue. This spinner, it's more likely you get a 1 than a 2. It's more likely you get a 2 than a 3, so it's not fair. Might be a little hard to read, but there's a game with the spinner, which kind of looks like a flower. You get 1 point when the spinner lands on blue or green. Your friend gets 1 point when it lands on red. And the first person to 10 points wins. Is the spinner itself fair, ignoring the rules? Is it equally likely that you would get any one color if you spun it? Yes. There are 2 blue, 2 green, and 2 red. If we think about the rules, which once again, you get a point if it lands on green or blue, and your friend gets a point if it lands on red. And the first person to 10 wins. Is that fair? No. You have a higher chance of getting a point than your friend does. So your probability of a point, this is how we can write it without having to write it all out. Probability of getting a point for you. Out of the 6 segments, 4 of them get you a point. So that's 2 out of 3. I want to get 10 points. I get a point 2 out of every 3 times I spin. 2 points for every 3 spins. Sorry. 3 spins. 2 points for every 3 spins. But I need to get 10 points. So how many spins will that be? If I was lucky, 2 times 5 gives me 10. So 3 times 5 gives me the 15 spins that I would need. What if you get 1 point when it lands on blue or green? Your friend gets a point when it lands on red or blue. The first person to 5 points wins. Is that fair? Yes. You each have a 2/3 chance of getting a point.